Dear colleagues, let me present a case study which was created with a software solving mill. We entering the solving mill. Here, on the home page, we are creating a new project. Open it. Now we are in Temple, which will help us to solve a problem step by step. Let's describe a problem situation. 100 years ago, a ship with a cargo of ancient pieces of pottery sank by the Korean coast. It was absolutely impossible to recover the cargo because the ship was laying in a depth of over 100 meters. There was no diving equipment because it wasn't invented yet. However, archaeologists were surprised to discover that the vases from the sunken wreck were starting to appear in fishermen's houses. When they asked fishermen how did they manage to recover the vases from that depth, the fishermen answered that they used a fishing rod. The question is, how to recover ancient vases from the seabed using a fishing rod? So there is a problem situation. Now we need to order the information. What is important? The undesirable effect is vase absence, inability to recover it. The useful product is the vase in a boat. The production process is an operator fishes out the vase from the seabed with a fishing rod. The next step is to analyze a machine which produces the useful product. Here is a machine scheme. A machine operator with a fishing rod. It provides a process fishing out a vase. The useful product is already known. A vase in a boat. The harmful product is an absent vase. Let's fill additional element of machine description. A machine function is to recover vases from seabed. Machine components are an operator, a fishing rod, a vase, a boat. Machine structure is the following. An operator is situated in a boat. A fishing line is in the water from water surface to seabed. How does a machine work? An operator lowers a fishing line in water, hitches a vase which is laying on the seabed and lifts it on a sea surface. So a machine and its work are understandable more or less. But we have a main question. Which operation of a process causes a problem? Let's use the operator problem operation researcher to investigate the production process deeply. Now we need to construct the production process operation by operation. The first operation is lowering a fishing line in the water. Its performer is an operator with a fishing rod. The product is end of the fishing line on a seabed. The next operation is hitching a vase. The performer is the same. The product is the vase attached to the fishing line. The final operation is lifting the vase to the boat. The performer is the same. The product is the vase in a boat. Let's define a problem operation. No problem with lowering and lifting, but we don't know how to hitch fishing line to the vase, because it is impossible to hitch in with a hook. It's necessary something different. Mark it as the problem operation and enter the harmful product, the vase which isn't attached to the fishing line. Save the result and close the operator. The scheme of the problem operation appeared in the template. Now we can pass to construct conflict scheme. The harmful product is the same. It's the vase which isn't attached to the fishing line. To find the work object, we need to step back. Previous state of the vase is a vase on a seabed. A negative action is to prevent attaching the fishing line to the vase. Which tools does implement this action? Deep water. A conflict place is a seabed area near the vase including place of the fishing line end. Conflict time is time when the fishing line end is situated near the vase. Then we need to find conflict causes. Solving will propose two operators for this purpose. But in our case, causes are understandable, so we can skip that to pass to hypothesis suggestion. Let's use the operator hypothesis manager. We have four special tools for hypothesis suggestion, but we can also generate hypotheses in the free mode. The hypothesis is a conflict can be eliminated if the fishing line attached to the vase and reliability holds it. Let's analyze the hypothesis for passing to a problem model. We have not hypothesis for united. We can formulate a final solution, which is required according to the hypothesis. Select variant provide the performance of an action in the system. Indicate the action attaching and holding. The action is provided in the operation zone. Our variant of this advantage is the action is insufficient. Based on entered information, solving mill generates the structural problem model. It is necessary to intensify the action attaching and holding of the tool, the fishing line, on the work object a vase. Save results and come back to the template. Now we have draft of the problem model. The statement and the goal are filled automatically. We need to complete the operation zone and resources. Operational zone is the fishing and the vase, water near them. Substance resources, an operator, a boat, a fishing rod, a fishing line, and so on. Field resources, water pressure. Time resources, the fishing line before lowering and the fishing line end is situated near vase. Space resources, area near the vase and the fishing line end. Space inside the vase. What is next? We can try to solve the problem step by step in the template or use the operator TI transformer. The operator assists us to transform a problem model into a solution model and then to a technical solution. Let's indicate a tool, an action, a work object. It is tau scheme. The tool is the fishing line, the action is attached and hold, the work object is the vase. What should be improved? The necessary action is insufficient because we cannot attach the vase to the fishing line. Select the corresponding variant. Solving mill recommends several variants of transformation. Let's see. Focus the action. Here is the prompt with example, which help to better understand the essence of transformation. No idea how to focus the action. This one. Introduce an additional tool. We already have one tool. It's the fishing line. We need something additional. Now we have the automatically generated solution model. Intensify the action by introducing into the system a new component, an additional tool. Do we know the additional tool? No. Solving mill asks which kind of a component we need by describing its attribute. What size? Corresponding to vase size, similar or smaller. Shape also depends on the vase. A component should surround the vase or fill it inside. Component surface should have adjustive property for better attached to vase surface. Material of component should be resistant to water pressure. A component should be dynamic because it must find the vase and adapt to its shape. Controllability is the very important attribute in our situation. Let's see prompts, which variant of control we need. We already have manual control. Component controlled automatically, it's what we need. It is the key requirement. A component must independently find and attach the vase. It can be a robot, but no robots in the early 20th century. Now we can use a list of requirements to find unnecessary resources. Solving mill presents all substance resources for analysis. Operator, boat, water, sea animals. Let's check. Some of them can live and act in deep water, about 100 meters. Material is okay. They can hide inside caves and can change shape more or less. So, shape and dynamicity are okay. We can say that they are controlled automatically. For example, we can use some behavior feature. Close the dialog and check the resource. Fish and other sea animals. The best animal for our goal is octopus. It often hides in small caves and it's very difficult to pull it out. Solving mill asks how we need to transform the octopus. Skip the question, because we don't transform it. But the system should be transformed. We need attach to octopus to fishing line. So it is attributes structure links. Check the attribute and write to tie up the octopus to the fishing line. No necessity to transform other components and other actions. And as a result, solving mill presents automatically generated solution. Formulation is raw. Let's edit. To attach the fishing line end and the vase, introduce an additional tool, the sea animal octopus. To tie up the octopus to the fishing line, save the result and close TI transformer. We have the solution in the template. Now we can add an illustration and indicate advantages and disadvantages. We generate the final solution. There is no need to add anything to the preliminary solution. So we have finished solving process. Here is third phase of project, composing technical proposals and estimating conflict elimination. It is important for real problems, but our problem is training one, so we can skip the third stage. Let's generate a project report. We obtain the HTML file in which are presented all our actions, images, models, solutions. In the last part of a report, you may find a useful feature, draft of patent claims. You can use it for further preparation of patent application. Besides reports, solving mill storages project in the template form. Thank you for your attention. Good luck in problem solving.